first of all some important concepts, and then we can start working on past paper questions. Let's start from work. So what is work done? Work done, simply this is equal to force time distance, and but distance you need to understand, this is the distance moved in direction of force. Distance moved in direction of force, so we can say in direction of force. So you have to take that distance. So distance moved in direction of force you need to consider is very important point. Most of the time many students they make mistake with this one. Distance moved in direction of force. For example, imagine that this is the box is here, this box is placed here. If I apply force F on this one, you can also understand in this case the force is acting on this block, weight of this one is acting down, and there is a normal reaction force that is acting up. So if I ask you to calculate work done by this, so let's say it moved this certain distance, so this distance is d, let's say this distance is d. If I asked you what is work done by normal reaction force, and if I ask you what is work done by W, so can you please tell me what is work done by W, means gravity in this case. Work done by gravity you will simply say is equal to 0, because box is not moving in direction of gravity. Gravity is acting vertically down, so work done 0. If I ask you what is work done by normal reaction force, also you will say is 0. And if I ask you what is work done by applied force, so you will say work done by applied force, this one is equal to FD. So you need to understand, when we talk about work done, we talk about work done by force and distance moved in direction of force. So very important point, you need to be very clear about this one. And the second thing you need to understand, if we have for example this box, so if there is an angle, let's say this force is applied at an angle, so let's say this one is the force. Box, let's say covers certain distance, so you can also take this is the distance, so it travels this distance. So in this case when you need to calculate work done, you need to understand work is done only by this component of the weight, and this component, if this angle is theta, so this one has to be F cosine of theta. So in this case W has to be equal to FD cosine of theta. Simply you can say horizontal component of force you have to multiply by distance traveled, and that is component of force that is pushing this one forward. Mean this component of force is in direction of distance, mean distance moved this way and force is also in the same direction. Simply you can say this component and distance moved in direction of this component of force. So this is how you can calculate work done. And rest of the things, for example, you understand kinetic energy, this is 1/2 mv square, and you need to understand net work done by net force, work done by net force. So how we can calculate that? Work done by net force, that is equal to change in kinetic energy, means work done by all the forces. If you add that work done, that has to be equal to change in kinetic energy. And this is work energy theorem, very important, very powerful tool in mechanics. We use this one to answer many mechanics problems. So this is called work energy theorem. So this is work energy theorem, very powerful tool. And also GPE, for example, is not a big deal, is a very simple concept, but let me highlight, this is mg delta h. So what we calculate actually in our calculations is we calculate change in potential energy. We always take reference point. Okay, is very important. Imagine that this is a simple pendulum. Let's say this one is here. So you can imagine then it is at lowest point, then it is at this. So it is oscillating like this. Now in this case, if I take my reference point here, this is the ground. Most of the time we take ground as a reference point. So this has certain height here and it has certain height here. So this one we can say h2, let's say this is h1. So at this point it has only GPE, that is mgh2. We are assuming h here is equal to 0. So at this point it will have kinetic energy plus it will have GPE, because it has height. So most of the time what we calculate is change in potential energy, because we take one reference point. Very important point, you need to understand this one. And also you need to understand conservation of energy. Conservation of energy, some important concept I just want to highlight, then we will start working on problems. Conservation of energy simply means that total energy remains constant, means E initial, this has to be equal to E final. If no air resistance or no friction, then we can also apply conservation of mechanical energy. So can you please tell me what is mechanical energy? Conservation of mechanical energy. I want to see, do you understand what is mechanical energy or not? So please write down what is mechanical energy. Then I will explain you what is mechanical energy. First, I want to hear your answer. Can you type what is mechanical energy, please? Okay, mechanical energy, please, simply you need to understand mechanical energy is sum of, I can say mechanical energy, this is sum of kinetic energy of the system plus potential energy. So if no resistive forces, so here we are saying no resistive forces. No resistive forces means no friction, no air resistance, no resistive forces. So then mechanical energy is conserved. So we will say ME initial, this one will be equal to ME final. So the mechanical energy, then in that case, mechanical energy is conserved. So you can use conservation of mechanical energy and you no need to worry about resistive forces. So this is how you can use conservation of mechanical energy. And also one other point you need to understand, power. Power is equal to work done. So this is simply work done over time. And what is work done? Work done is a mechanical way to transfer energy from one object to another. For example, if I want to transfer energy from myself to this mouse, I can raise this one. So I did work on this one. So its potential energy increased. So the energy is coming from my body. I transfer to this one. So this is work done is simply way of energy transfer. So we can say work done is equal to energy transfer, and this one we can divide by time and we can calculate power. So this is energy transferred over time, total energy transfer over total time taken. So you can calculate average power. Average power, then you will calculate if you take total work done by total time. And also work done, we understand this is equal to FD over T, but D over T, distance over time, this is equal to velocity. So we can say power is equal to FV. So this is another way to calculate power. So we can calculate. So one last concept I want to write on here, that is efficiency. So efficiency we can understand is, this is useful energy, please. Efficiency is useful energy out, means output energy. So I'm just writing energy output, but this is output energy divided by total input. So divided by total input energy. So this is how you can calculate energy. Useful, very important, not the output. Output, input, always same. But what we consider in efficiency, useful. So we can calculate. You can also calculate this one if you have useful power out, P out. You can divide by P in, you can calculate. Sometimes you need to calculate percentage efficiency. So then simply what we will do, we have P out useful, this is useful. So, and we will divide by P in and we just multiply by 100. So in this case, you will calculate percentage efficiency. So these are some main concepts about this chapter. And we will use this knowledge now and we will answer problems from this chapter. So let's go to problems now and answer. If you want to take screenshot, you want to save this one, you can take screenshot and then I will go to next one. Okay, please look at this question. Very nice question and not very difficult one, but I hope you can answer this. So this is the answer, a question you can see. And first of all, try by yourself. Okay, so please try this one by yourself and type your answer. Okay, so type your answer, please. Okay, please type. After 2 minutes, I will explain. You can type your answer. Answer is C. Okay, so let me see. Just wait. Okay, I think you need to try again. Okay, you need to recheck your answer. Okay, after 1 minute, I will explain. Okay, for this one, please, you need to understand. We have the light lamp. So this one is the lamp, or simply you can say this is light bulb. So what is the input energy to this one? So input you need to understand is electrical. So this one is E in. So we can say this is input energy. Now what we want out of this one, or what is coming out of this? Energy is coming out of this in two different forms. Main two different forms we have. One is light. So one is light in form of light and also in form of thermal energy. So in form of thermal energy is coming out. Okay, so this one. Now we need to understand. Okay, answer is B. Okay, just wait please. I think not B, not C. So let's try to understand now. Now in this case, which one is the useful? What do we need from the light bulb? We expect light. So light is useful. So this is the useful energy, useful form of energy. and this one is the wasted form of energy. So this one is wasted energy. So we need to calculate efficiency of the lamp. Useful is given to you, this one is 8 joules, and this one is given to you is 90 joules. So the efficiency we need to calculate, percentage efficiency means percentage, so it means useful. So which one is useful? Light is useful, and which is wasted is 92. So what is the total? Light plus thermal, so it means this is light plus thermal. So this is the total energy. Total means this one is equal to electrical, so you can also say light over electrical. So electrical is here, so you can calculate from output, you can calculate input, and this has to be multiplied by 100. So you see we have light here, this is 8 joules, and electrical total energy is 8 plus 92, so multiply by 100. So we are coming up with 8% only, because 100 is cancelled with 100. So the answer for this question is A, please. This is the answer, not B, not C. Okay, I hope this is clear to you. So this is how you need to approach these problems. Okay, answer is A. Excellent. So answer is A for this one. Let's move on to next one. Okay, let's go to next. So this is how you need to answer. Next question also is about efficiency, so let's go to next. Okay, please try this one first of all by yourself, take some time and type your answer. Okay, please try this one. So you have to use the same concept. Okay, you can type your answer when you finish. Okay, you have 1 minute more, still you can type. Okay, it's 120. Yes, your answer seems good to me, so I will check. Just wait. So here is the answer, please. D is the right answer. Okay, so D is the right answer. So let me explain to you, because only one of you just type answer. So let me explain to you. First thing you need to understand efficiency. So we can write down efficiency that is given to you. So we can start with efficiency. So we need to start with percentage efficiency. So this is useful E out. We have power in this case, so useful P out divided by this is P in. So percentage efficiency is given, that is 60%. It means 60 divided by 100. So and output mechanical and means output is given, mechanical output power is given, that is equal to 120, and this is useful. So we can calculate total P in. So you can write down this is 0.60. So here you have 120 and this is divided by P in. So if I need to calculate P in from here, so this will be 120 divided by 0.60. So you will get 200 from here. So this is over P in. Now this is P in. So how about the wasted? So we can say P wasted. So we can say wasted power, wasted P out. That one is equal to P in minus useful P out. P out. So simply you have 200 minus 120, you will get 80. So this is how you can approach. So the answer for this one is D. Okay, I hope this is clear to you. Very simple approach. Now we will go to next problem, little bit harder than this one. So let's move on to next. If you have any questions until now, you can type. Otherwise, we will just keep on moving to next problem. Very nice question on efficiency. I hope you will try first of all by yourself and you will try your answer. This is very nice question. Okay, please try to answer. Take time, read question carefully, and then type your answer. This is also about efficiency. So let me write down here again. Efficiency. I will just use symbol eta for this one. So we have energy out, useful energy out. So I'm writing E out divided by this one has to be E in. Okay, so what you need to do is, so this is here, please. This is, so I will just leave blank here. Later we will plug in here what we will get for E out. So this is the useful. So very important, not only out, useful. And here we have total input energy. So I can say this is total input. Okay, so please try this one now. Take some time and try to answer. Okay, so when you finish, you can type your answer. Okay. First of all, please look at this now. How we can calculate E out, energy out. So in this case, you see power station output is given. They didn't specify this one. It simply means that this is the useful output. So this is useful output power. So it is not specified, but you have this one is useful. Now, if I need to calculate energy output, I can simply use P out multiplied by time. So energy is equal to power over time. Energy is equal to power times time. Power is equal to energy over time. So what is the power out? This is given. So now I can simply replace this one with P. So this is power. How about the time? Number of seconds in one day are given to you. It means this one is the time. So I can simply write down here. So this is the E out, power out. The E out, this is power out and total is E out. So I can simply write down here. So this is the P out. Because you can see the answer now, but still we can work on E in. So E in now. So E in, how we can calculate this? Look at this now. Number of trains per day are given to us. Number of trains. So we can write down here, we have trains. Number of trains per day are given to you. So I can simply write down here. What else we have? Mass of coal on one train. So we can say mass on one train. So you have mass per train is given to you. Mass per train is given to you. What else we have? We have energy from 1 kilogram of coal. Means energy per kilogram we have. So this is energy per kg you have. And this is the mass in kgs. Now if you see this one, you can see very clear now. Number of trains cancel. Mass in kgs, mass in kgs cancel. You can do by units. So this is the energy per time. So this is the E in. So what you need to do? Trains per day. Trains per day. So this one is N. And what is mass per train? This is given is M. So what we have? Energy per kilogram. Energy per kilogram. This one is J. So this is the total input energy. So simply I will write on here. This is NMJ. So the answer for this one is A. So A is the right answer. So this is how you need to approach. This is problem solving skill. Okay. I hope this is clear to you. And let's move on to next one. So the answer for this question is A. So let me check. This is the answer, please. Okay, let's move on to next one. If you have any questions until now, you can type. Otherwise, I will just keep on moving to next. Here, very nice question. Not very difficult one, but bit tricky. If your concept is not clear, you will get stuck with this. Okay, please try to answer this now. Take time. You have 2 minutes and then type your answer. I will explain you step by step. First of all, just try by yourself. If you can find answer, it's wonderful. If not, I'm here to explain. Okay, let me show you the answer, then I will explain. Answer for this question is D. If you have got this answer, that is right. Wonderful. If not, now follow me and let me explain to you how to calculate answer for this. You need to understand, first thing, it is given to you a box of weight 200 Newton. It moves at steady speed, means speed is constant. So resultant force is 0. So this is what this is telling us. Height of this one is given. The ramp, angle of the ramp is given. Frictional force acting on the box is given. What is work done by the person? Now you need to understand, this person has to push this box. You can imagine that this one is the box. This is the box. I place here. I push this one this way. If I need to move this one with constant speed, I need to apply force equal to the resistive forces. So now we need to understand how many forces are acting on this one. One is the resistive force. This is the friction actually. So it's given to you frictional force that is acting down, and we can say this is F, small f, and this is equal to 150 newtons. What else is acting on this one? Means is there any other force acting on this one? Yes, because this is the weight, and weight has 2 components. So we can resolve into 2 components. So it has 2 components, and one component is along the plane and is pointing downwards. So we can resolve into 2 components. This angle is 30 degrees. So if this is 30 degrees, this one has to be 200 sine of 30 degrees, because this is opposite angle. So it means there is a force on this one that is also acting, and that force we can draw here, and this force is 200 sine of 30 degrees. Now if we can find this distance, means from here until it reaches the top, so until here, this distance if we can find, then we can calculate the work done. So work done here. So this is the D. If I need to find D, for example, so simply you can understand sine of this angle. This one will be equal to 1.5 divided by D. So if I need to find D, so simply I will divide 1.5 divided by sine of 30 degrees. But sine of 30 degrees is equal to 0.5. Sine of 30 degrees is equal to 0.5. So this is sine of 30 degrees. So we can say this is 1.5 divided by 0.5. So if I divide this one, so you will get 3.0 meters. So it means this distance is 3.0 meters. Now simply we need to calculate work done. It's asking you work done by the person. Now the question is that how much force this person has to apply. The force applied by this person. So this force you need to calculate. This force. This one. So this is the force we need to calculate. And this force has to be equal to these two forces because it has steady speed. So resultant force is 0. So F net is 0. So in this case I will say this force F, I can say capital F. This is equal to friction plus component of weight plus 200 sine of 30 degrees. Now simply you can use W is equal to Ft. F in this case you have 150 mean the frictional force plus we have 200 sine of 30 degrees multiplied by distance. Distance we have calculated 3 meters. And if we solve this one, your answer should be 750 joules. So this is how you can calculate work done. So this is how you can answer. Okay, I hope this is clear to you. If you have any questions, please, you can type your question. If not, I will just assume no questions and we go to next one. So maybe one more question we can do. So this is how you need to approach. Let's move on to next one. Okay, this question is okay. Let's say this is conceptual problem. Okay, can you please try to answer this now? This is conceptual concept. Okay, please try to answer this now. Maybe one more question. So we just left few minutes. So try to answer this now. First of all, try by yourself. Read question carefully. Try again, Sentry. I think answer is not A. Try again, please. Try again, please. Answer is not A. I think answer is not A. But I will explain later, but you can try again. Okay, I will explain after 1 minute. Okay, so let me explain to you, please. Answer for this one has to be this one. A is not answer. Why answer is this one? Because it is given to you, it is moving at a constant speed. So if the speed does not change, how about the change in kinetic energy? It means kinetic energy also will not change. So that's reason answer for this question is A. So you need to read question carefully, please. So the answer for this question is D. A is not answer. This is just tricky question. If you miss this piece of information, it means you can't find the answer. So you need to read question carefully. Okay, so the answer for this question is D. So let me check answer. Yes, answer is D because speed is constant, so no change in kinetic energy. Okay, this question is bit long, but let me explain you. I will explain you just this one. You have 1 minute, you can try this one. Otherwise, I will explain. This question may be a little bit long. So first of all, please, you can try. You have 1 minute. You can answer if you can answer. If not, then I will explain. So I will write down some points here for you. First of all, you need to understand. Okay, you can read question. You can try. You can try to answer by yourself. I'm writing this one because we are running out of time. There is no A resistance. So the total loss in GPE is equal to total energy at this point. So at this point, total energy, if I say E total, this one is equal to GPE because it is starting from rest. So it is given to you, it is starting from rest. So if I go to this point, at this point, the total energy, this is equal to kinetic energy. I mean, this is also equal to E because our reference line, we are taking this is the reference. Okay, H is equal to 0 here, so it means GPE here, this is equal to 0. Now total energy is equal to E, so it means kinetic energy at this point is equal to E, but mass is not given. So let's see how we can approach. So the total energy, I can say 1/2 mv square, this one is equal to E. But in this case, you see speed is given, so we can find speed is given is 4, so we can solve this one. So we can find out in this case E is equal to 8m. So this is the total energy. So E is equal to 8m. M is the mass, so mass is not given, so we cannot calculate mass now. Later maybe we will be able to calculate. Now what question is asking us, at which point the loss of potential energy is equal to E by 4. So now you need to understand GPE lost, this one has to be equal to kinetic energy gained. So this one has to be equal to kinetic energy gained. But GP lost is given, that is E by 4. So we can write down this one is E by 4. And kinetic energy gain kinetic energy gain. So this one has to be equal to 1/2 mv square. So any speed, we are taking any speed, that is the speed at that point. E by 4, E is equal to 8m. So we can say this is 8m divided by 4. So we have here, this is 1/2 mv square. So we can simplify this one. So we will get 2m here. Now next step is you can cancel this m with this m. So v square is equal to 4. From here we can say v is equal to 2. So the speed at that point is when it has lost E by 4, speed is equal to 2. So speed is equal to 2 meters per second. So the speed is at this point. So the answer for this question is B. So this one is the answer, and this is how you can approach this problem. Take care of yourself. Bye for now.